Did you know there are massive rivers flowing, not on land, but deep within our oceans? These aren't just streams of water. They are the planet's climate control system, and right now, they're facing an unprecedented threat. What happens if this system breaks down? Stick around to find out. You're looking at ocean currents, the colossal conveyors of heat around our globe. Imagine them as a planetary-scale circulatory system. It all starts with something called thermaline circulation. That's a fancy term, but the concept is simple. It's driven by two things: temperature, that's the thermal part, and salinity, or saltiness, which is the Halon part. Here's how it works in the cold polar regions. The ocean water gets very cold and dense. As the ice forms, it leaves behind salt, making the surrounding water even saltier and denser. This heavy water sinks, pulling warmer surface water from the tropics to replace it. This creates a continuous, slow-moving loop that spans the entire globe, a massive current moving incredible amounts of water and, crucially, heat. Let's look at a real-world example, the Gulf Stream. This powerful current acts like a warm water highway, carrying tropical heat from the Gulf of Mexico all the way across the Atlantic to northern Europe. Without it, cities like London and Paris would have winters as harsh as those in Canada at the same latitude. The Gulf Stream is the reason much of Western Europe enjoys a temperate climate, making it habitable and agriculturally productive. It's a perfect illustration of how these unseen ocean rivers shape the world we live in. But it's not just about warming one region. These currents are part of a global balancing act. They distribute heat from the equator towards the poles, preventing the tropics from getting unbearably hot and the polar regions from getting even colder. This intricate dance regulates weather patterns worldwide, influencing everything from monsoon seasons in Asia to rainfall in the Americas. Climate models show us that without this heat distribution, our planet's weather would be far more extreme and unpredictable. Now, here's the alarming part. This delicate system is under threat. As global temperatures rise, massive ice sheets in Greenland and Antarctica are melting at an astonishing rate. This isn't just adding water to the ocean. It's adding a huge volume of fresh, cold water. Remember how the circulation is driven by dense, salty water sinking? This massive influx of fresh water is less dense. It sits on the surface and disrupts that sinking process, effectively slowing down the entire conveyor belt. Scientists have observed that the Atlantic Meridional Overturning Circulation, or AMOC, a key part of this global system, has weakened by about 15% since the mid-20th century. This isn't just a number in a scientific paper, it has real-world consequences. A slower current means less heat is transported north. This could trigger more extreme weather events, like severe cold snaps in Europe and North America, and shift rainfall patterns, leading to prolonged droughts in some regions and intense storms and flooding in others. We're talking about a fundamental disruption to the climate we depend on. The impact doesn't stop with our weather. Ocean currents are also the lifeblood of marine ecosystems. As the deep, cold water travels along the ocean floor, it picks up rich nutrients from decaying organic matter. When this water eventually rises to the surface in a process called upwelling, it delivers a feast for phytoplankton, the microscopic plants at the very base of the marine food web. These nutrient-rich upwelling zones are some of the most biologically productive areas in the world's oceans. They support vast populations of fish, marine mammals, and seabirds. Everything from tiny krill to the great blue whale depends on this nutrient delivery service. If the currents slow down, so does the transport of these essential nutrients. This could lead to a collapse in fish stocks, devastating not only marine life, but also the millions of people who rely on the ocean for their food and livelihoods. The delicate web of life in the sea is intricately tied to the rhythm of these currents. Faced with this potential crisis, scientists around the world are racing to understand what's happening. They're using an arsenal of cutting-edge technology, from satellite altimeters that measure the height of the sea surface to a network of autonomous flows called the Argo Array. These robotic sentinels drift with the currents, diving down to measure temperature and salinity, and then surfacing to transmit their data back to labs on shore. This gives us an unprecedented, real-time look at the inner workings of our oceans. This data is crucial for refining our climate models and predicting how the currents will change in the future. The more we understand, the better we can prepare for the impacts and, hopefully, take action to mitigate the worst effects. It's a monumental task, but the health of our planet depends on it. The ocean's currents are a powerful, silent force that has shaped our climate and sustained life for millennia, but they are vulnerable. The changes we are witnessing are a stark reminder that our actions on land have profound consequences in the deep ocean. Protecting this vital circulatory system is not just about saving polar bears or preserving distant ecosystems. It's about safeguarding the stability of our own climate and the future of human civilization. We all have a role to play, from supporting policies that reduce carbon emissions to making conscious choices in our daily lives. The challenge is immense, but so is our capacity for innovation and change. Thank you for watching. If you found this video insightful, please give it a thumbs up, subscribe for more content about our amazing planet, and share this with others. Let's keep the conversation going.